So in today's lecture, we will be discussing about Huffman coding, which is a very popular code redundancy technique. So here in this method, two main steps are going to be followed. So the probability ranges which is given in your question is going to be arranged in descending order. After that, the bottom two probabilities are going to be added and we are going to get the next set of probabilities. Again, in your next stage, you are going to keep proceeding by placing the probabilities in descending order and adding the last two probabilities and get the reduced codes. So here I'm just taking an example. Here the symbols from A1 to A6 and the probability equivalent for these symbols are given here in this question. So for our case in image processing, we can just consider that these probability ranges are like our pixel values. So here, based on whichever values are being redundant, we are trying to reduce it. So this is what is this is going to be a very important image compression technique, which is going to fall under the variable length compression technique category. So here in this example, the symbols are given, and for this particular symbol, what is the probability range is also given. So for this problem, so the first step, as I already told you, we are going to be arranging the probability ranges for this symbol in descending order. So first, the symbol that I am going to take is A2, which is going to be, I am just putting a table over here for the symbol and the probability followed by the source reduction. So we keep doing the source reduction and until we get the final two probability ranges, we are going to keep proceeding with the same procedure. So the first I'm going to arrange my symbols in descending order of the probabilities. So first I've taken A2, which is 0.4, followed by A6, which is again 0.3. After that we have A1 and A4. So A1 is 0.1 and then A4 is 0.1 again. After that we have A3, which is 0.06, and A5, which is 0.04. So I've arranged the probabilities in descending order. So this is going to be the first step now. So next we are going to reduce the codes. So the first step of code reduction. So as I already told you, we are going to take the last two codes and probabilities and add them together. So these two probabilities are going to be added together, and again the probabilities, you will keep pushing the same probability to the next block, but then when you add these two probabilities, the added value should also be arranged in descending order. So again, the same protocol of arranging the probabilities in descending order has to be followed. So if I add these two together, I am going to get 0.1. So what I do is, so now if I arrange it in descending order, since it is going to be 0.1 again, so it is going to fall at the bottom of my probability values only. So it's going to be 0.4, 0.3, 0.1. This 0.1 goes over here, and these two probabilities are getting added and it becomes a 0.1 over here. So now, when I add the final two probabilities, what I have to do is, I have to give a code word for this. So I'm going to choose a 0 for this position, and for this position I choose a 1. It can be either way also. You can use 1 and 0 also. It depends. So we are just giving the code word over here. Okay. So this is going to be the first stage of source reduction. So next we are moving on to the second stage now. So again, the same protocol is going to be applied, wherein I am going to add the last two probabilities, and when I add it, again I am going to put the new probability ranges in the descending order. So these two is going to add up and give me a 0.2. So since it is going to give me a 0.2, this 0.1 is going to come at the bottom, and this 0.2 is going to move to this position. So my 0.4 will come back again, followed by 0.3, and then this 0.2 would go over here. Again, this 0.1 would come over here. So this is going to be the next stage. So as I already told you in the previous step, you are going to be giving a code word 0 and 1 over here for this code words that is being added. So again, so this is going to be my stage 2 of reduction, and then I am moving on to stage 3 of reduction. So again, in my stage 3 of reduction, I am going to add these two probabilities. So now, if I add, again I get 0.4, 0.3, and this is also going to be 0.3 again. So So I also give the code word to be 0 and 1 over here. So next reduction. So I go to the fourth reduction now. So when I move on to the fourth reduction, I add the final two probabilities, which is going to give me a 0.6. So this one goes over here because I am arranging the probabilities again in descending order. So this goes here and this 0.4 comes over here. So again I give a 0 and 1. So 0 and 1 over here for the codes. Okay. So now, as I already told you, we have to go up to 2 last probabilities. So with that, we are going to stop it. So we have received 2 probabilities over here. So with this, I am going to stop. So I just give a 0 and 1 and I stop with this. This we have to proceed with giving the code words. Okay. So in giving the code words now, so you are going to backtrace and get the code word. That is how this Huffman coding is going to work. So first we are going to target this 0.4. So this 0.4, where did it come from? So in the stage 3, it is you are going to backtrace it and get the codes. So now this 0.4, the code that you have already given is 1. So I am backtracing that value over here and giving the same code for this 0.4. So I am getting a 1. So the code word for 0.4 is going to be 1. Similarly, we move on to this 0.3 and 0.3. So now this 0.3 has, if you backtrace it, it has come from this 0.6. So you already have a code word given for this 0.6, which is 0 over here. So what you are going to do is, this 0 code word is going to be added before this code that you have already given over here for this 0.3. So this 0 is going to move over here. Similarly, the same 0 is going to move over here. So this 0.3 and this 0.3 are given 2 different code words over here. This is what we have got. So now again I am backtracing and going to the second reduction. So this 0.4, as we already know, it's going to be 1 over here also. So it's going to be a 1 here. And this 0.3 again, this is directly coming from here. So 0 and 0 is going to be the code word for 0.3. Similarly, this 0.3 is coming from this 0.2 and 0.1. So whatever code word I have given for this 0.3 has to go over here in the front. So I am adding 0 and 1 as a code word here for this 0.2. Similarly, the same 0 and 1 is going to go over here. So this is going to be the code word for 0.2 and 0.1. So again we are backtracing over here and going to the first reduction. So 0.4. So there's nothing done over here. So directly I am taking the whatever code word was given in the previous stage, and again for 0.3 also I am going to take the same code word that is given. And this 0.1 came from here. So which means that 011 is going to be the code word for this 0.1. Wherein this 0.1 has come from this 0.2. So for this 0.2 we already have a code word 010. So I am adding 0, 1 and 0 as a code word before the code that is already existing. So again the same thing is going to go over here. So 0, 1, 0, 1. So this is how we get the code words using Huffman coding. So after this we will proceed with the average length calculation and the entropy calculation. Again, for these probabilities we have to backtrace it. So for 0.4 probability, previously you didn't do any split up over here. So the same code word that you have fixed will come. And for 0.3, the same code word, this 00 is going to come. And for 0.1, so it is going to be 011, which you have already got in the first reduction. And 1, the code word is backtracing from here. So it is going to be 0100. And then this 0.1 probability is split from 0.6 and 0.4. So this will go over here to the front. So 0, 1, 0, 1, and it is splitting over here also. So 0, 1, 0, 1. So this is how we are going to get the codes using Huffman coding scheme. So after the Huffman coding, the codes are being calculated. We are moving on to calculating the average length for the Huffman codes that we have calculated. So the formula for calculating the average length is going to be summation of the probability ranges with the length of the codes that we have obtained. So here for us we have the values over here. So the probability range is 0.4 and the code length for 0.4 is going to be 1 plus 0.3 is the next probability and the code length is going to be 2. Okay, so you have 0 and 0, which means that the length for the code word that we have fixed is 2. So followed by the next probability is 0.1 and the code length is going to be 3. And then we have 0.1 again. And for 0.1 the code length is going to be 4 plus 0.06 and the code length is going to be 0.015 plus 0.04 into 5. Okay, so if you perform summation, if you calculate this product and sum it up, the number of bits that we are going to be getting is 2.2 bits per pixels. So this is how the average length is calculated for the Huffman coding scheme for the reduced codes that we have obtained. This is how the average length, capital L, is calculated. Compute the average length, we are moving on to calculating the entropy. So the formula for calculating the entropy is going to be the probability values log base 2 of the probability values again. Okay, so if you expand this expression, we will be able to get the entropy for the codes that we have calculated. So the probability ranges as per our question. I'm just expanding this the values as per the question that is given. I'm just expanding the expression that is given. So once you calculate once you substitute the values in the expression, we get around 2.14 bits per pixel. So which is going to be the entropy value for the Huffman coding scheme that we have computed. And then, so to understand the efficiency, so for us it is going to be a compression technique that we are trying to do over here, which means that the efficiency of the compression technique is what matters. So we are going to be calculating the efficiency for the code words that we have done. So to calculate the efficiency, we are going to divide the entropy with the length. So we have already calculated the entropy value is already computed here, and we have already discussed about how to calculate it. Similarly, we have also calculated the length of the Huffman coding scheme. So when you substitute the values of entropy and the length, we get around 97%, which is going to state that the efficiency of the overall scheme that is proposed. So this is about Huffman coding. To summarize on, so Huffman coding is a compression technique, variable length compression technique that's very popular in doing. So it usually has only 2 steps in doing it. So you will be given the probability values present. So the probability values is going to be arranged in descending order, and then you keep reducing, adding the last 2 probabilities, and you move on to the next step. So these 2 steps are going to be proceeding until you get the final 2 probabilities. So this is how you get the code words. Thank you.